Hello, esteemed participants. Today we invite you to be part of a crucial endeavor as we explore the enrichment and processing of solid minerals in Kazakhstan. We're excited to invite you to participate in an important survey, which covers best practices and technologies for mineral enrichment and recovery. Your input is invaluable in helping us understand the current state of the enrichment and processing industry in Kazakhstan and identifying potential areas for improvement. Please scan the QR code to open the survey questions. Your participation is completely voluntary, and your responses will be kept confidential. Thank you.
Well, good afternoon, everyone. Welcome to what is the last session of this forum. It's been a very interesting 2 days, I think. I hope you all agree on that. And although we are the last session, I'm sure it's a question of the best being saved for the last. And we're here to listen to various presentations on metals processing and recovery. And of course, that's possibly the most crucial part of the whole mining operational cycle, although I'm saying that as a mining engineer, but I acknowledge the skills of the processing end of the business. So I think it's going to be a very interesting session, and thank you for coming. Can I just urge you to take part in the survey? If you haven't got the QR code, it'll come up again, and hopefully we'll have a few minutes at the end just to go through that. So the presenters will be coming up to the podium and make their presentation, and then I think we might have a few minutes at the end of each presentation to have some questions from the floor, if there's any. So please, if you have a question at the end, put your hand up or approach the microphone, and we'll see where we go. Okay. So, I think our first presentation is from Mr. Alan Clarke, Technical Director of Wardell Armstrong in the UK.
Okay, thank you very much, and thank you for coming to this last session. I know you're all wanting to rush off to the gala dinner, but thank you for coming here and listening to us first. I'm looking at tailings from a geology point of view, and looking at them as a potential resource for future recovery. So as we all know, mining activity has been vital for the economy of many countries, but because global resources are finite and the continued population and technology advances with a focus on renewables is increasing pressure on natural resources, making use of all of our resources will be vital in the future. Now, mines typically follow a set path from prospecting to development, to extraction and finally closure. But does this always mean that this is the end of a mine's productive life? The mining process results not only in the production of metals, but also a generation of waste products that are stored in the tailings facilities. These facilities are often classed as waste and potential liabilities with significant safety and environmental issues to overcome. But this burden could be minimised if mining companies change their perception and start to use these disused facilities as a potential resource. Now, since the solid phase from tailings might contain remaining valuable metals that were not recovered in the past, they represent potential resources and could be the objects of assessment studies and eventually reprocessing. The potential resource of any tailings facility is dependent on many things, including the amount of material, the mineralogy of the original ore, the mineral or minerals targeted in primary processing, and the nature of that processing and the efficiency of recovery. An assessment of tailings facilities for their economic value must consider all of these things and determine what quality the remaining mineral can be recovered. So, what is the potential scale for the exploitation of tailings? We have some statistics for the worldwide picture. Now, following the collapse of a tailings facility in Brazil in 2019, a global tailings review was convened with a goal of establishing international standards for safe and responsible tailings storage. And part of that work was to establish the scale of the potential problem. But during that review, the scale of the generation and storage of tailings worldwide estimated that approximately 8.9 billion metric tons of tailings are generated annually. Tailings are stored in an estimated 8,500 currently active, inactive or closed tailings facilities. And worldwide, stored tailings currently exceed 280 billion metric tons. Now, within these tailings, there was an estimated $3.4 trillion of precious, critical, and strategic minerals. Now, we need to assess these tailings facilities and understand which ones of these facilities are processable and to what extent. Now, tailings are going to be unique for every deposit in terms of scale and composition. As we said before, the amount of ore processed per unit of commodity produced will vary with the type of deposit, the mineralogy of the original deposit, the quality of the ore, the quantity of the ore, and the mining methodology chosen for primary processing that may increase or minimize diluting material sent to the processing plant. The global tailings review we talked about concluded that the largest producers of tailings worldwide are copper at 46% of the total, gold at 21%, and iron at 9%. And together they make up about 76% of the total tailings material. A continuing trend globally is likely that the amount of waste material generated per unit of commodity will increase over time as overall grades decline and lower grade deposits are exploited. This trend of exploiting lower grade deposits is partly likely to be driven by increasing metal prices, and two things are therefore likely to increase the focus on old historic tailings facilities. The first is that the same increases in price that allow the exploitation of lower grade deposits also bring into contention the reprocessing of lower grade materials that were originally below the cutoff grade of deposits a long time ago. And the second is that changes in focus in the industry may drive interest in historic tailings, and commodities that were previously considered as waste or a contaminant now become sought after as technology develops and changes. So the primary focus of most initial assessments is likely to look at the potential of recovering high-value material by identifying and targeting tailings at deposits mined at a time when prices of the material were much lower than today, or where processing or certain eras of processing were inefficient by today's standards. The two obvious target areas for this type of research are tailings facilities of historic gold and copper mines. As we can see, the gold price even in the year 2000, which is relatively recent, was only $250 an ounce. The copper price was $1 a pound. Metal prices for those commodities now are 4 times or more that, depending on when you look at the spot price. Also, over time, head grades of gold and copper have reduced, and figures suggest that copper and gold head grades dropped 7.6% and 13.4% respectively. Higher head grades in the past may have allowed inefficient processing and recoveries to be ignored or masked in a way that today's deposits would not allow. Initial searches therefore focus on deposits where high head grade and masked inefficiencies in processing, deposits where processing was inefficient for the deposit mineralogy, and deposits where the mining cutoff grade was high compared to today. So there have been some success stories in this. One of these is the Kunrad project here in Kazakhstan. This operation, copper is recovered from waste dumps that originated from the Kunrad open pit mine that operated between 1936 and 2005. And the target material consists of a combination of oxides and low-grade sulfides, so it's not a simple mineralogy, but the success of the operation is based on the fact that it can take advantage of the material has already been semi-processed, hence there are low costs for no drilling, no blasting, no transport, and these outweigh the lower grades and recovery that might typically be seen at an in-situ copper deposit. The low cost is further driven by the process methodology chosen, which consists of in-situ leaching of material followed by solvent extraction and electrowinning. So Kunrad has identified a resource, it's identified a low-cost base that can outweigh the recoveries and grades, and has identified a process methodology that fits with the mineralogy of the remaining material. So, also, an assessment of tailings facilities or dumps for re-exploitation should not simply focus on the primary metal or minerals originally targeted. As technology changes and as the green revolution accelerates, minerals such as rare earth elements are now seen as vital commodities where they're previously seen as a contaminant or waste and not targeted. These metals are vital for supporting the electronics industry and the green revolution, and with currently 90% of rare earth elements supplied by China, there's a focus on finding these materials elsewhere. As an example, there was a 2016 study that focused on the Kiruna iron ore deposit in Sweden that found rare earth elements in the tailings facility at quite high concentrations. And whilst economic production was difficult to secure, the tailings are now considered a potential important strategic resource for the EU. So in addition to that, ambitious plans for electric vehicle usage worldwide will require a lot of lithium for battery generation. And whilst many new lithium-focused projects are in the planning stages, a new mine to obtain lithium is not necessarily required. New techniques allow the recovery of lithium from lower-grade material or dump low-grade material at mines, but they've also been found in waste facilities where the original mineral targeted was something completely different. For example, we can see lithium recovery from bauxite mine tailings, but also completely unexpectedly Rio Tinto explored for gold in borates tailings in the USA, but at the same time, they found higher grade lithium concentrations than many US projects already under development. So the best place to start reviewing and ranking tailings deposits to determine potential for value is processing plant records. We look at historic process plant records to look for the information that we would find equivalent to looking at an in situ deposit that's still in the ground. And these records will likely hold information recording the time period of tailings deposition, the volume of material deposited, estimated plant recoveries at the time, estimated grades of the tailings and process methodology, and etc. Now, information from these records can be viewed against the primary geological and mining data of the deposit, including the ore mineralogy, which may have varied over time, and mining head grades. The next stage of the process will be to identify the best prospects and treat them in a similar way to any prospective in situ deposit by drilling and sampling using a suitable methodology to gather representative samples to carry out a mineral resource estimate and, most importantly, collect material for the processing test work. The results of this mineral resource estimate and the test work, if positive, will then form the basis of an ore reserve estimate. The drilling methodology chosen will vary depending on the depth of the tailings, accessibility, stability, and moisture content of the tailings. But drilling can be anything from auger drilling to standard reverse circulation drilling to sonic drilling. And sonic drilling has proved effective in difficult ground conditions such as tailings and other soft unconsolidated ground because it provides you with an in situ undisturbed sample that's very good for selecting or for identifying changes through the depth of the tailings and for selecting metallurgical samples. The mineral resource estimation process for a tailings facility follows a similar procedure to any other in situ deposit. You need to be able to domain the deposit by identifying the base of the deposit, the current surface level, but also looking at historic plant records to get individual time periods through the tailings facility in order to domain the deposit effectively and constrain those domains by periods of targeting different mineralogies of the in situ material or different recovery profiles of the process plant. But perhaps the most crucial part of this stage will be the results of that metallurgical test work. These metallurgical samples must be composited before test work as a reflection and knowledge of the tailings facility. If the mineralogy of the ore is known to have changed over time and variation is expected within the tailings facility, then the makeup of the samples must reflect this. And it's always worth remembering that the commodity under investigation will not be recovered during primary processing, and it must be clearly understood why and what can be done to recover it during processing. So I'll finish up there because we've got 1 minute left. So in conclusion, exploitation of lower grade material mineral deposits becoming more common, and process technology has progressed over time to allow the processing of lower grade deposits such as tailings. By targeting and exploiting these historic tailings facilities in stockpile, sustainable and profitable mining operations can still be carried out. These tailings may have been deposited in times of inefficient processing methodologies and may have grades comparable to in situ deposits exploited today. Benefits of exploiting these deposits include a reduced cost for processing, which may offset or pay for any costs of transport and movement. So reprocessing the material come with challenges, not least of which is that material was not recovered in primary processing, and it must be clearly understood why not and what can be done to recover that mineral during processing. Okay. Thank you very much. Thank you for your time.
Thank you. Thank you, Alan. Very interesting. There's an old adage, I think, that today's tailings dam is tomorrow's mine, and I think you're presentation clearly shows that, and I think we all realize in Kazakhstan that there is enormous potential here for the so-called technogenic deposits, not just tailings dams, but some of the smelter slag heaps. We have a number of copper and zinc smelters operational in this country, have been operating for decades, and their slags contain valuable constituents. So I think there's an opportunity there that needs to be looked at. Any questions from the floor for Alan? No? Okay, well, let's move on then with our next speaker, who is, sorry, I've got spectacles on, David from Somerset.
Yes.
Is that right? Thank you.
Thank you. I really appreciate all of you coming. It's the last presentation of the last day. So I'd like to give you all a gift. And the gift is I'd like to introduce you to an innovative technology whereby mineral processors can significantly increase their output and their revenues by applying this technology to their tailings flows. And similar to Alan's discussion, he's looking at capturing minerals from tailings ponds. Our technology is a step before. We apply it to the tailings stream at the actual beneficiation plant. So I'd like to introduce you to our company, Somerset International. It was founded in 2008, headquartered in the US, and we specialize in recovering ultrafine particles from tailing flows. And this technology is unique and patented. We've got an R&D center in Brisbane, and we are continuously innovating our technology. And not only do we have an innovative technology, we have a very innovative business model. The way we work is we design, build, install, and operate our system in existing clients' processing plants. So basically, the client doesn't have to pay any money for the installation or the operation or the maintenance of the facility. So we like to call it asset light. And the way we get compensated is we get a share of the value of the additional tons that our system captures. So if our system operates well and we can capture an additional 10 or 15 tons per hour of product, and the market price is high, it's great, everybody's happy. However, if our system for some reason doesn't work or the price is low, the client pays us accordingly. So we're taking all of the market risk for the price and the performance risk for the installation. Right now we've got 32 operations in US, Canada, Australia, and Russia, and we're expanding we're looking at new markets like Morocco, South Africa, Philippines, Brazil, and now Kazakhstan. I spent the last 7 years implementing this system in Russia, and unfortunately, because of sanctions, we can't grow our business there anymore, so we'd like to move on to Kazakhstan, hence why I'm here. So the way the technology works is we build our system inside the processing plant, or if there's no room next door to the processing plant, and we use ultra-high-speed centrifuges to capture ultrafine particles. And then sometimes we'll install flotation and then our centrifuges to dewater and separate the minerals from clays and then all of the water that runs through our system, we recirculate back into the plant. So we avoid tailing ponds. And the way we engage with customers, this unique business model, is we're not selling equipment, we're a service provider, and we enter into, let's say, a 7-year contract with a client, whereby, again, we design, build, install, and operate the system, so there's no capital expenditure and no operating expenditures by the client. And we also don't interrupt the existing plant. So the plant's working, and we build our system or install it inside the plant, and we connect to the flow of the waste, and if for some without interrupting the factory works. So why we think this is attractive for clients is we increase revenues. You know, we typically produce 10 to 20 tons an hour of additional product, or let's call it 100 to 150,000 tons of additional product a year, which we deliver back onto the main product conveyor of our client, and they sell it, and then we get a share of those revenues. And there's no capital or operating risk for the client. Again, if the thing doesn't work, we don't get paid. And it's a turnkey solution. We do all of the design, all of the government permitting, which in Russia, I'm sure, well, in Kazakhstan, I'm sure it's a similar system to Russia, and it's, permitting is not easy, but, we've got a team of 30 people in Russia that have designed and built and operate our systems, and we think we can easily transfer that knowledge to here. And we also recover water back into the plant, which is, very important. I've read that Kazakhstan is, has some issues with water, not as bad as other markets we're looking at, like Morocco and Jordan, which, in the deals we're looking at there, they don't even care about the additional product. They just want us to preserve their water. And we also reduce the amount of waste. So this kind of fits in if someone wants to get some ESG points with the markets or their lenders or the government. If we're capturing 100 to 200,000 tons of additional product a year, that's an additional 100 to 200,000 tons that aren't being dumped into the environment. So that's a big plus, and we're trying to get some of the ESG halo for ourselves, even though we're operating in the terrible mining and even worse coal industry. We're reducing the negative effects of this. And a typical deal will take us about a year to go from our first meeting with a client to installing our system. We spend an awful lot of time at the beginning analyzing and designing the system, because the way our business model works, we've got to invest, let's call it $5 to $10 million into the project, and then hope it works and hope we get paid. So we want to be damn sure that this is going to work, because if it doesn't, we've lost $5 or $10 million. And the agreement we make with our clients is, we say we've got to produce a minimum of X tons an hour at this moisture and this ash level, and if we don't, you can kick us out, and we're screwed. So we want to make sure this thing's going to work before we invest in this. And to date, we've invested about $100 million of our own capital. Here's a few of our clients. I'm sure you're familiar with some of them. In Australia, we work with Peabody and Anglo-American. In the U.S., we've got several contracts that, every 6 months we get another contract with Warrior, which is a big met coal manufacturer. And this is what the systems look like. On the far right, at the top, this is our system in Australia where because of the weather we could leave it outside. And so we've built all of this, which you can see a column flotation and then a 4-level building with our centrifuges. So these are, you know, serious installations. And here are a few examples of projects. You know, one project we're looking at is recovering phosphates. I mean, to date, we're focused primarily on coal, but we want to move into other minerals. And I know there's a big phosphate company here in Kazakhstan, and we're actually looking at phosphates in Russia. Interestingly, there's a little, you know, phosphates aren't sanctioned because the world needs phosphates, because the world needs food, so there's a potential phosphate company there. But this one we're looking at, we have the potential of capturing an additional 1 million tons a year. I mean, this would be a massive project with 40 centrifuges. This is the Australian one I showed you previously. I mean, over the past 5 years, we've captured an additional $100 million of revenue for the client. And this is a deal where it was a 5-year deal that expired in 2022, and they said, hey, let's keep it going for another 5 years. Because for them, it's free money. I mean, they don't have to pay anything. And there's a lot of maintenance costs involved. We've got employee costs, replacement parts, and the client doesn't have to pay anything. So they're happy for us to stay around for another 5 years. This is one we built in Russia. The green building is the existing plant, but they didn't have room. So we built the white building next door to it, which is a 3-level building. Over the past year, we've produced 100,000 tons of additional product for them. So time is running out. We'll end on ESG. Again, we capture about 95% of the valuable minerals in the stream. So that's, again, reducing those minerals that are dumped. And it allows, instead of dumping kind of wet tailings into a pond, you can do dry disposal since we've dewatered the resulting cake. And it improves water usage. So we think all in all it's a great proposition for clients. Increase revenues, no capital costs, no operating costs, and get some points for your ESG report card.
Thank you very much. Yeah. Thank you very much, David. Very interesting, very appropriate technology for this day and age. All these things are what we have to do. And of course, as you say, you can make more money as well at the same time. So it's all good. Any questions for David from the floor? No? Okay, we will then move on to the next speaker, Mr. Galimjan Nurlanov, General Manager of Weir Minerals.
Don't mind, I will proceed in Russian. Уважаемые гости форума.
Dear forums of the forum, I am Nurlanov Galimjan. I am the General Director for the company Weir Minerals for Kazakhstan. The topic of my presentation for today, innovations for smart, effective extraction of minerals, application of AI in it. Let me brief you about the company. The company Weir Minerals now is known as the producer of the equipment and solutions for mining enterprises, and we have a big net of production facilities, casting and servicing centers worldwide. But recently we have started to work in the area of introduction of AI in the mining enterprises. What are the problems that the companies that work in the mining industry face? This is the ore level is reducing, transfer to green economy, which requires considerably increase to use the metals and minerals, ESG principles, ecological and social goals, improvement of the electrical power consumption, reduction of the negative impact on the environment, and number 4, the lack of the qualified personnel. The future of the mining industry, how do we envision it? How do we see it? We need to introduce innovations, efficiency, sustainable development. It means that we need to take care about the environment. And to achieve this goal, we need to optimize the processes through introduction of new technologies. In order for this to work and operate, there should be some integrated system for enrichment factories, which means that we need to introduce the strategies of preventive maintenance, improve the operational efficiency of the enterprise, strengthen the measures of security, and thus we shall increase the performance of the enrichment factories, decrease the negative impact on the environment, and thus we shall get the optimized process for decision making. How to become an integrated system, a plant, a factory, how to translate it into the factory. For it, we need to digitalize all the critically important elements as equipment, processes, systems. We need to tune and to launch our networks, cloud facilities, to have our instruments. We need to have the digital platforms for analytics, for your AI, for your analytics, and for machine learning. And also, a very important factor is transformation of culture, approaches to management, management of the operational activity of enrichment factories. All this together creates the digital twins, which enable to monitor the equipment, to optimize the processes, an opportunity for preventive maintenance, and opportunity for risk management. The problems that are faced and which are happening now, and which is the production enterprises in mining phase, as was followed. We have two approaches in the relation. First is the human method, where the operators introduce their parameters based on their experience, based on the obtained information, depending on the expectations of the future of the processes, and on the basis of such data and on the human management, the factory will be functioning. The other approach, expert systems, the so-called EPC and PC, in the companies which deal with automatization, they know all well about it. Advanced process control model, predictive control, automatic systems of the process management, they work on the linear models. If you look at the graphs, presented to your attention. They work on the basis of the linear approximation of non-linear processes, which means that in case of fluctuation of technological operational processes in the factory, we have to recalibrate the whole system. To change the entry parameters, we need a long time to change the processes, but to change the process a long time, which limits us in terms of rapid decision taking and reduces the performance of the enterprise and the efficiency of its performance. All the systems are static, and that is why, as I have already said, we have periodically to recalibrate them for the non-linear system of the production facility. And also these systems are limited and become not important in a year and a half. What are the solutions which we propose? We propose to introduce AI. How it works? The system recommends to establish the entry parameters for control on the basis of the data that the system gets from the existing factory, on the basis of the model of the enterprise working, on the basis of forecasting the future processes, and it analyzes hundreds of possible trajectories of these non-linear processes in the work of the factory, which means that you can pass over from the linear model of non-linear processes to non-linear model of non-linear processes. And the system also is learning itself. With the time, the system sees and learns how the processes change in order to be in the optimized status. In order for this to happen, data will be the super important element for the system. But sometimes we don't have enough of data. We know that AI works on the basis of data, but not all production facilities maintain historical data, or maybe they don't have any historical data due to the lack of the technical solutions to collect and store such data. That is why we can use physical models. On the right, you see a circle. These are physical models. On the left, they are the data. And while having all this in place, you can combine all this for effective performance of the enterprise. We call it a hybrid system with the support of AI. AI is used. If in the enterprise we have SCADA or GCS, then AI can be used at the top level and can be introduced. We are not proposing to change your existing system, SCADA or whatever. It's put on the top. If you have the service or MPC, ATC, dispatcher servicing, AI can be established on top of the system. A step-by-step approach to full optimization of the processes. We understand that the production facilities have good historical data, but it's important to consider the process of optimization as a long voyage. Starting from a small volume of data, you start from the bottom and you go up the stairs, and the majority of operations have not got the level of maturity because they have to do the first steps as establishment of sensors, collection of data, and the more data is available, the results are better. So, to sum up, I want to say that the introduction of AI is a long-term liability or commitment, and step by step, it will be possible to introduce it. In the past, the company Minerals, and now you know us as a producer of mining equipment and the local solutions, but now starting from the end of last year, we procured the company which deals with AI in mining, and now we're actively developing this direction. Now we are preparing several products in the segments. We do have solutions, or preparation, classification, and tail management. This is it. Thank you for attention.
Thank you very much.
Спасибо.
Very good presentation, and very interesting, your last points about AI. Now, this is something that we've heard mentioned in quite a few presentations in the last 2 days. I'm just wondering what it'll be like in, say, 2030, 6 years from now, at a MINEX conference. Will we be talking about AI, or will we be talking about something even bigger and better? Or will it just be all robots? I don't know. But I feel we're on the very sort of brink of a whole new world in mining with this very cutting-edge technology and the things it can do to make mining more efficient, safer, cheaper. Great. Any questions from the floor? No? Okay. Could we move on then to our next speaker? Thank you. Mr. Pavel Smez.
Yeah, I know it's difficult.
I'm sorry about that.
Yeah, no problem.
Thank you very much.
My last name is difficult in all possible languages, so yes, I'm quite kind of unique. I'll be delivering in Russian, but feel free to talk to me in English. Да, добрый день еще раз, дорогие друзья.
Yes, good day, dear friends. It's very pleasant to survive up to the last session. I want to thank the organizers once again. Thank you very much. Professionally arranged session. I want to thank the translators because very, very difficult texts. It's very difficult, and in this regime, that's why it's very hard work behind it. Yes, all these 2 days we have been discussing very interesting visiting topics and in an interesting manner about the energy transformation, decarbonization, green technologies, and so on and so forth, and the ESG, of course, and where the ESG is present in my presentation. Yes, it's fair, it's justified, and we can talk about the importance of all this stuff, but I shall not be repetitive. I want to be very concrete, specific, to talk about the technologies, which is right now can be applied by you with this goal. This is the technology of today. It is ready today to become to be used in the energy transformation, because the technology is ready. Let me tell you about it.
So let me tell you some words about our company. Steinert is a German company that is located in Köln. The company is a dual company. We celebrate 135 years anniversary, and right now we are located in Köln. So nowadays this is a global company, but the main office and the main production site is there at the place where it was 135 years ago. This is an interesting fact. Our company started its history from the magnet sorting machines and separators, and now we have been still doing it till nowadays. However, in the beginning of 21st century, we were one of the first to come to the area of sensor-based sorting, and nowadays we are we are the leaders. The technology is still young, and we've been developing it since the beginning of 20th century, as I mentioned. But more and more it becomes more popular, and it conquers other markets. And again, try not to be modest, I want to say that the future is in this technology. So a couple more words about Steinert. We are the global company. The company has a different representative office and branch offices all over the world, about 500 employees. And we are not the global giant. However, we are not a small-scale company. So this also speaks for itself. And I also want to add that our company has still been working with magnet equipment, with sensor equipment. We do waste recycling, metal recycling, but we are not talking about this. We are speaking about mining. What is multi-sensor technology and sensor-based sorting? From this name, you can understand that the material would be scanned by different sensing devices using different technologies, and the information is being processed about this scanned material using the specific algorithm, and then there is a command to have the specific physical action, so to do the sorting. So what technologies we are using for this sorting? Well, first of all, we are speaking about X-ray technologies, X-ray transmission and X-ray fluorescence. X-ray fluorescence is the spectral analysis. Transmission is a bit different. It's X-ray impact. Besides X-ray, we use laser scanning, color scanning, induction sensing device, and we use near infrared range. So the machines that we are using, let me now show it to you, but the machines, they are universal. They could be used for any type of materials. For example, we can use it for anything. There are no specific machines that this is only for coal or only for iron or only for copper. Our machine is a universal one, and it could work today with the coal, then tomorrow it could be moved to the copper or to the gold. And of course, we have to adjust and fix the settings, but the machine itself is the same. So this is the way it looks. So it's like 40-foot container, the size of it, so that we would understand the size of it. The material would be fed from the vibra feeding device to the conveyor belt, to the machine itself. The speed of the conveyor belt is 2.7 meters per second, so it's the usual speed. Then it is scanned at the scanning area, and then until this material would go to the end of the conveyor belt, the machine has already known what to do with this. So we have the beam of the pressed air, and there are some specific valves, and then each rock, each stone would be sorted. If it's the waste, if it's the tail, it would go forward, and if it's the product that we need, the machine would put it to the product area. So this is how it looks. You see the video from the left side. You see this technology, XR transmission, and then you see how the materials would be sorted. So the technology XRT allows us to scan. So X-ray would go totally through the material, and we receive this picture. So we scan the material, and we can divide it based on the density. For example, if we want to separate our sulfide or some other ores or some other minerals, they are heavier rather than some other rocks like calcite or some silicates. If we speak about coal, it's a different case. Our product would be light fraction, but our waste or our tails would be of the heavy fraction. However, the technology is the same, it's a universal one. What else is important? That we have the nuclear density of the material, and we also use here laser scanning. It gives us two effects. First effect is that with the help of the laser ray, we identify the form and the thickness of each piece of each rock, and it's the additional parameter to our calculation. And then laser is a beam of light which is aimed or targeted, and we see the dispersion for each material different way. In some materials, this beam would not be disseminated. However, if we have quartz or ore bearing or gold bearing ore, then we can identify these gold veins and we can separate them from the waste. So speaking in more details, what else we can do, where we can apply, what we can receive using this technology? Well, first of all, we can use it for our primary ore, so that to work with the dumps. During these 2 days we were speaking about it for a lot of time. We increase efficiency of transportation, and we can use it in other different ways. So after the secondary crushing, before moving it to the other stage, the material would be sent to sensor-based sorting machine, and here we do the preliminary enrichment. So at this stage, we are moving out all the tails. So at this crushing or grinding stage, we have the preliminary enriched material. And you can understand that this is very good saving or economy. We do not use water. We decrease the energy consumption critically. We reduce the amount of wastes, and so this is the way we usually do it. And if we have some other ores that are not into our production site, it's the same way. So we put some specific settings, and our machine would be working. We would eliminate all the tails or all the base row, so the tails would go to the tailing point, and this preliminary concentrate would go to the further enrichment. So we can increase the efficiency of transportation. So this is a very important problem and relevant problem for Kazakhstan and for some other things. So we have sometimes the case when our enrichment plant is away, or the distance is quite long to that enrichment factory or site. So, and if we want to reduce our transportation costs, so here at our coal mine, we could do the sorting. So tails would go to tail pond, and or if we do the underground work, it's a different way. And then we transport already preliminary enriched material. So it's not the 100% of base, let's say, rocks. So we have already a preliminary enriched material, not poor rocks. So this is the example. This is our gold-bearing ore, and this is underground mine in Japan. So here you see the frame. We see 41%. This is with the tail. So we were able to sort 41% tails, and we lost gold a bit more than 4%. So the extraction of gold is more than 95%. This is just one of the examples. And the final enrichment, and what is really relevant in the context of our forum is, to work with the dumps. So we put our machine at the dumps, and additionally we have the production, and we produce the product from our tails. So my time is over, but I still have lots to say. But I hope, I tried to give more details, and I think that all our beautiful words about ESG, they are also useful, and I hope it was interesting for you, and I am ready for your questions.
Here, the entire presentation looks really interesting, and another great technology here available to improve operations and efficiency, save money, make more money, etc. So are there any questions from the floor? Yes, welcome.
Производительность?
The question about productivity. It's a right question because productivity is not endless. The main factor of productivity is the class of the size of the material. The less class, the less productivity. The higher the size, or the bigger the size, the bigger the productivity is. But it's difficult to say, it's a totally different topic depending on different issues. However, approximately, if we speak about the big rock or big size, for example, we are sorting the coal. So here we can have about 200-250 tons per hour. If it is a finer material, for example, the gold ore, and the size is not so big, then productivity would be about 40, 60, 70 tons per hour. I mean, everything depends on the specific case.
Anyone else? Any question? Okay, Pavel, thank you very much.
Thank you.
So, our final speaker in this session and for this forum is Mr. Esko Takola, Business Development Manager for Sidra Minerals Processing.
Good afternoon, ladies and gentlemen. My topic here is the passive sonar flow monitoring technology that has become an industry standard for slurries. Sidra is an American company providing solutions to optimize the performances on concentrators. Passive clamp-on sonatrack measurement is the only new flow measurement technology developed during the last 40 years. It's been on the market 20 years. It installs around the pipe. Even for big pipes, it's very lightweight, easy to install, not affected by the slurry properties. It has a multiple measurement capability, measures the volumetric flow, also the volume occupied by bubbles, and based on those one, we can correct the errors the bubbles are causing for density measurements, so you get better mass balances. And there are diagnostic measurements on the flow itself and the process, how running stability. There are no moving or wear parts, it's totally maintenance-free. It has a long lifetime. We have customers that have had it on pipes for 20 years without no maintenance. So you can avoid all kind of process shutdowns because of critical measurement failures. It's versatile, it installs on a wide variety of pipe materials, and it also is an effective data logger, so it enables remote diagnostic capabilities. Installation is simple, you just clean the pipe, take the sensor mat, tighten it around the pipe, and connect it, put a protective cover onto that, and connect it to the transmitter that is then further connected to your DCS system. And like I said, so it's an efficient data logger. You can pick up 1 month data histories with 2-second intervals on that with an USB stick and send it to us for analysis. We can do the actual optimizations according to the actual flow model in the pipe totally remotely. Here, a good way to compare performances of flow meters is to install similar flow meters on both ends of long lines. Here we have one case of 3 kilometer long and comparison between sonar and electromagnetic, and you can see the variability that is seen in magnetic flow meters when the densities are varying. Because magnetic flow meters are measuring the ionic content, and in water those are evenly distributed, but when you have gravity included affecting on solids, there will be problems and variabilities. Additional process measurement information is provided by the gas volume fraction measurement, so the volume of the bubbles, and based on that we correct the errors for density measurements. Then we do have a flow quality signal, real-time information on the stability of the flow at the measurement position. So it's revealing all disturbances in the process caused by segregation or air content or pumping problems. And the sound pressure level is measured also, and the sound is coming from the pump, so it enables pump analysis and reveals pump service needs. Here we have one case that in a small sump which is feeding the cyclone battery, the free fall coming into this small sump is taking lots of air into the pump. And because of the compressibility of the air, the pump is losing already the pumping capacity. So for a few hours, customers have been losing up to 30% of production because they are pumping air partially instead of slurry. It's a very common problem, especially in older facilities where the design capacities have been later increased, but the sumps are still the same. We see it often also still in greenfield projects also. Then the density measurement correction. If we take a theoretical slurry without bubbles, there always are bubbles in slurries. And the specific gravity, so the density of that is 1.4, and the density measurement is showing that. And then we add 10% of bubbles in the volume, then the density measurement is showing only 1.26. So there is already 28% error in your mass balance. As density measurement is measuring the difference between water and slurry, so the closer to the water is the slurry density, the bigger error is caused by already 1% of air in the slurry. So if this density is 1.2, so 1% is already causing 5% error in your mass balances, so density measurement. Of course, you can get with this the real production rate correctly measured, and also you can see always when air is causing problems for the process runnability. And the operators can immediately do right corrective actions. And when you measure it, you are able to control it. So minimize the aeration and avoid it and even prevent it. And then you are minimizing the recovery and runnability losses caused by air, because air is actually quite a big factor on causing variability in the process runnabilities at concentrators. Diagnostic information on the flow. So we are measuring the propagation velocities of all sizes of turbulences that carry the solids forward in the line. This gives information on the real flow model at the installation position. So we can optimize this measurement to work much better than any other flow measurement that are calibrated to measure fully developed turbulent flow of water. And that model is never actually present when you have slurries, because there is always the gravity effect affecting the solids distribution in the pipe. The flow model is monitored by flow quality factor, a real-time signal giving information on users on flow disturbances in the line. And you can even set alarm levels to that signal so that the operators know now that there is something wrong in the process runnability. Here we see a picture where the convective ridge of turbulence is separated for the carrier liquid flow, and then there are solids flowing with a lower flow velocity. So this kind of segregation leads into density pulsation that causes filter blockages and improper cyclone operations, and also line blockages. Typically in concentrators in Western world, it's said that 1 to 2% of the process production time is lost because of line blockages. Here we see a cyclone battery feed line, and the flow quality is dropping down, showing that segregation is starting, and a dense plug is formed into the vertical feed pipe. After a while, that dense plug is so dense that even the flow velocity drops down. Then the pump rushes that plug into the hydrocyclone, but we can see from the flow quality that the new plug formation has been started. So continuous density and flow pulsation in that feed line, which is ruining the operation of hydrocyclones. Diagnostic information on pump operation is given by Sonatrach sound pressure level measurement, and it informs on the stability of the pump operation. Here we can see how the flow quality has had sudden drop downs, and simultaneously also the sound pressure level has collapsed. It directly tells us that now you have problem with the pump. So you need to do pump service there. So the value of Sonatrach is that there are no measurement drifts, and they last throughout the process lifetime. There's no wear, no maintenance. Like I said, already 20 years without maintenance or stoppages or any kind of maintenance needs. No contact to flow in hazardous materials, so that's a safety issue. Alike that there are no flanges when you install it. It works with thick wall or lined pipes and scaling applications, so you will have higher process uptimes. And the entrained air measurement we already discussed about, and it's the same meter for whatever it's flowing in whatever kind of pipe. Already over 70% of the world copper is produced utilizing Sonatrach, as an example. Combined with the CIDRA-provided CycloneTrack PST, which is a particle size measurement from every cyclone overflow pipe in a battery, real-time measurement. These two put together to optimize the grinding circuit has proven out to bring optimized net metal productions at our customers. Some have reached even up to 10% increases in concentrated net metal productions. We look forward to discuss with Kazakhstan customers. So welcome to meet us. Perhaps not to stand anymore, but for example, the gala dinner time. Come on and grab us and discuss with us. Thank you very much for your attention and patience staying here even for the last presentation.
Thank you, Esko. Very interesting. What looks like a simple installation, but very robust, and you can get a wealth of data and process management out of it. It's very interesting technology. Thank you very much. Any questions from the floor? Please.
Hi everyone, my name is Yersanay. I'm from Weir Minerals, key account engineer, Kazakhmys and Karmet. Just as I understand, correct me if I'm wrong, by this device we can replace the conventional nuclear density meter, correct?
No. Okay, we can correct the errors that the bubbles are causing to those measurements in real time.
Okay. Because it's very challenging using nuclear density meter every time. You need a special storage. You need lead times every time. So, okay. Do you have any reference where this system working? I mean, in Central Asia or closest place where I can go with my customer and see it?
So, do you mean Sonatrach or CycloneTrack?
Both.
Okay. So, here in Kazakhstan, we do have few customers. For example, Gaz Minerals is utilizing this. In South America, USA, South Africa, there are 700 concentrators utilizing Sonatrach. Over 100 of them utilize only Sonatrach for slurry flows. Then this cyclone track PSD is utilized by, for example, by 10 of the 20 biggest copper mines in the world. So 30% of copper is already produced under controls of that system.
Okay, thank you very much.
You're welcome.
Any other questions? Okay, thank you, Esko. Before we close, I think we just have a couple of minutes where we can look through the survey results and see what people think about the topics that have been picked. So we have 66 representatives of industrial enterprises here. I'd just say now that if you responded to the English QR code, then these are the results that we'll see from English speakers who responded. The Russian QR code may well have different results, but we will see that in the final presentations from the MINEX forum that will be put online, and you can pick them up there. So these are English speakers' thoughts, I should clarify. Okay. What types of minerals are most actively processed in Kazakhstan? Low iron ore. Okay, I don't know if ERG might contest that, but yeah, copper, gold, uranium. Uranium, of course, Kazakhstan, biggest producer of uranium oxide. Rare earths, ores, and metals. Yeah, that's, I think, quite accurate there, because the whole rare earth elements industry is really just developing, and it's a very tricky thing to get right, and it needs a lot of research, a lot of metallurgy to find an economic deposit. So that's still a big challenge, I think, ahead of Kazakhstan. How do you assess the current technological level of enrichment and processing in Kazakhstan? Well, it's 1/3 good, 1/3 okay, 1/3 low. Okay, I think that's, yeah, I guess that's about accurate in my estimation. But what is the importance of enrichment and processing minerals for the economy of Kazakhstan? 66% very important, as it's one of the leading industries. I think we all appreciate that. A few think that medium is not a priority for the development of the economy of Kazakhstan. I wouldn't agree with that. I think it's absolutely vital. Next. In which sector of the mining cycle will AI, machine learning, have the greatest positive impact over the next 5 years? Deposit targeting, exploration data gathering, exploration manipulation, mine modeling, not so much maybe. Process design optimization, well, we've been hearing something different here. Mine waste management, yeah, medium. Okay. What are the potential opportunities in Kazakhstan for re-exploitation of technogenic deposits from the following sources? We've already been listening to that in this session, so there's obviously an interest across the board of all the different alternatives: closed tailings, closed mines hosting unexploited remnants, mine waste rock dumps. We know that there is an active operation that we've heard about, Kunrad, smelter slag dumps, waste ponds, and coal ash dumps, and all the above. Yes, obviously, I think there's a definite signal there that the opportunities in technogenic deposits are real, and something that we need to really get involved in. What are the challenges and problems facing the enrichment process industry in Kazakhstan? Low recovery of useful components is critical. High energy costs, important. Lack of qualified specialists. I think that is a crucial thing in my experience here. Redundant equipment, environmental risks, they're more and more significant, as we've also been hearing. Lack of state support and legislative innovation. Yep, I think legislation needs to catch up with the times. So yes, quite interesting how people feel there. And finally, that's it. Okay, well, thank you very much, everyone. I hope you've all enjoyed yourselves and learnt something, and I know I have. So, yes, thank you to the organisers, and thank you to the translators once again for their hard work. And I think we're all free to go and enjoy ourselves now. Thank you very much.